All right, here in 2.6, we are on to trick number 2 for calculating limits at plus or minus infinity. And trick number 2 is going to look a bit familiar. It is to multiply by the conjugate. Okay, that was one of our standard ways to algebraically find a limit back in section 2.2, part 2. But here it gets a slightly different twist because remember, we have a trick that's been working for us quite a bit. This is the main trick that we try to use. Trick number 1, multiplying everything by the reciprocal of the highest power of x in the denominator. Okay, that is a really good one for these limits at infinity. Now, trick number 2, multiplying by the conjugate, is really something that we're going to end up using when there's not a denominator to work with. So if trick number 1 fails because there's no denominator, that's when you're going to use this trick number 2. So when there isn't a given denominator to work with. Okay, otherwise you'd just go straight for trick number 1. So this, for example, might look something like the limit as x approaches infinity of the square root of x squared plus x minus x. Now notice that plus x is underneath our square root and the minus x is outside of the square root. That makes a big difference. So those are not going to cancel each other out, mind you. Okay, so we see that this is an infinite limit, or a limit as x is approaching infinity. So our first instinct when you see that in the limit should be, oh, can I multiply by the highest power of x in the denominator? And on this problem, you would have to say, no, I can't, because there's not a denominator. So that's why we're going to multiply by the conjugate. So the conjugate of this expression would be the square root of x squared plus x, and then plus x. Okay. So you multiply by that conjugate, and remember, we can only multiply by 1, essentially, to not change the function. So we have to multiply by the conjugate over itself. So square root of x squared plus x, and then plus x over that exact same thing. All right. So we have a limit as x is approaching infinity. And let's go ahead and distribute here. All right, distribute, we'll have x squared plus x, and then beauty of the conjugate, plus x times the square root minus x times that square root. Middle terms cancel each other out. That's why the conjugate is so cool. And then for the last terms, we'd have minus x squared. Okay, so just distribute it on top there. And in the denominator, we will just have the conjugate itself. Okay. Now notice that we will have a little bit of cancellation up in that numerator. So now our problem looks like the limit as x approaches infinity of just x over the square root of x squared plus x. And this just turned back into a trick number 1 problem. Very similar to these previous examples 3 and 4 that we were just looking at in the prior videos. Okay, so let me make a little note here. Use trick number 1. Okay, so we're back to our old process at this stage. And we would look for our highest power of x in the denominator. Okay, remember we see an x squared right here, but it is under a square root. So that is effectively the same thing as x to the first. Okay, effectively. And I'm saying effectively because technically, yes, there's some other stuff underneath that radical, but as x gets very large, that term will act a lot like x. And so our largest power of x in the denominator effectively is going to be x to the first. So highest is just plain x. And so the reciprocal of that is 1 over x. And that's what we're going to multiply by. So times 1 over x in the numerator and denominator. Okay, so now we have the limit as x approaches infinity, a little distribution there, just 1 on top, and then 1 over x times our square root in the denominator, and distribute here, that would be a plus 1 outside. Okay. So you can see we're back to the old tricks here. This 1 over x is sitting next to a square root. So we need to write it in a compatible way. 1 over x as a square root would be square root of 1 over x squared. And so we're going to rewrite. Limit x approaches infinity. Square root of 1 over x squared times square root x squared plus x plus 1. That's our denominator there. That is all under 1. Okay. So yeah, now that we've written the multiplier in a compatible way, we can combine those radicals in the denominator. So we would have 1 over x squared plus x all under a single square root plus 1 all under 1. And then you can distribute. So it takes a little bit of doing, but we do get to a point where we can distribute this and simplify things down. Okay, so limits x approaches infinity. Down in that denominator, underneath our radical, we're going to have 1 plus, okay, x over x squared would be 1 over x. That's underneath the square root, plus 1, and that's all underneath 1. Okay, so you start seeing these familiar things coming back up. We now have one of those expressions that as x approaches infinity, this expression is going to approach 0, and that's the 1 over x right here. As x gets real large, that's going to get real small. And so we're going to get to put a 0 right there. So let's do that. Now that we're putting in that value of 0, stop writing limit. And you have 1 over the square root of 1 plus 0, and then plus 1. And so we have 1 over square root of 1 is 1 plus 1. So many ones. Our answer turns out to just be 1/2. So that's the limit of this function. Interesting. All right. Now in the next video, we'll look at infinite limits, which is a bit different from limits where x is approaching infinity. In infinite limits, that's going to be where the y values go towards infinity. So catch you in the next video.